Amdocs Global Services provides a broad range of delivery and operations services to our customers, tailored solutions for Amdocs customers. What do we do? We take our customers' requirements. Every customer has unique business requirements and unique workflows inside them. So we take what we have and we customize them to what their needs are. The requirements to scoping, what do we mean by that? The customer comes along, presents us with their unique use case and their unique requirements and customization needs. We go and analyze it, and we produce a scope of work document. That's the requirements to scope. Just to bring that down a level, requirements come in, we have a team, solution manager, they analyze the requirements and see how that fits in with the out-of-box behavior of the Amdocs products. Or this may be a change request, in which case we are understanding what needs to change with their current solution. We consult with the domain experts. The experts, of course, have to consult their documentation. And they come back, write the scope of work document, which contains a list of, it describes the solution, the efforts and the cost and the time frame. We give it to the customer. Customer can review it, make sure it's okay. If it's not okay, then it goes round the circle again until everyone agrees on the solution and the scope. So just a quick demo of what we have today. We built this tool here. At the bottom, you type in, this is for our internal team. We type in the requirements, use cases, and so on. The bot goes away, does some analysis, and generates a first draft scope document with all the details, the customizations, and so on and so forth. We can also edit parts of that document through natural language. We can do structural changes or ask it to do additional research and details. We also connected it to our Knowledge Assist tool, where we can ask general questions against our internal company documentation. So I think everyone here knows about RAG, so I'll skip over that bit. RAG is, of course, the foundation of a lot of tools that we have. So how might we automate this process of requirement to scoping? We could just use basic RAG, throw the requirements in the side, let it connect to the document repository, give it to an LLM, and throw in, of course, a document template, and out pops a scoping document. It looks beautiful. LLMs can produce beautiful looking text. Of course, if you look a bit deeper at it, you'll see it's missing something. It's lacking proper analysis. So this isn't going to work. So what have we done? Our approach is like this. We've modeled the research and authoring steps of the process as distinct items in our own internal workflow, specifically the research part of it. About a year ago, you may have noticed in the AI community and so on, the rise of the research agent. You can type into this thing, give me a document about underwater sea creatures that live at the bottom of the ocean. And it'll go away and search the internet and come out with some Wikipedia-style article, or maybe an archive paper or something like that. I also came across a research agent which isn't trying to build articles for you from doing that kind of research, but rather, if you have a large document, a very large document, with a complex story or something like that in it, you can ask questions on the story itself, which requires a lot of research. In other words, if you focus in on one part of the story, you don't get the answer that you want. You have to hop here and there and back and forth to be able to achieve that. So, zooming in on the research agent. So, one of the things these research agents do is multi-hop queries. What do we mean by that? Let's take an example query. How is a change of address handled in Amdocs products? So I look at all my thousands of documents inside Amdocs, not just the product documents, but all the customizations that have come over time. And I might not have a single document or single document chunk. Remember, we're talking about RAG here, which contains the answer to this question about change of address on all Amdocs products. So what we can do, we can break that question down. What are the Amdocs products? And the answer might be billing, customer management, order handling. And then we can create new questions, such as how is change of address handled in billing? How is it handled in customer management? And these are distinct RAG-compatible queries, which you're more likely to find the right answer for. So one of the challenges here is actually query generation. How do you break down these queries? How do you make new queries off the back of the answers of the previous ones? So it's a real challenge. What we've done is to sculpt a very elaborate persona and general big context to put into the prompt of the query generation itself. It works, it needs some improvement, but that's one direction. Looking further ahead, we may improve this by not doing so much query generation, but by leaning towards hard coding the research process. What our solution managers and architects are doing, there's a specific internal process going on in their head, which they're following, but it's pretty standard for their domain, and we want to capture that and maybe hard code that. But we can then take that a step further. We can describe that research process that they're doing in natural language and then use an LLM to orchestrate that whole thing. So that makes it more configurable and steerable. Oh, maybe some of you have heard about O1 from OpenAI. It's got superior reasoning skills, apparently. That might be useful. There's lots to say about that, but I'll just say our attitude is you really need to try these things. It might work, it might not. You don't know until you try. Now, talking about documentation, there's lots of challenges here with documentation. This is common to a lot of RAG systems. Today, we're taking in Microsoft Word, PDFs. By the way, our repository is not curated in any way. The internal Amdocs community of solution engineers and so on, they're contributing their documents to this repository, and it can come in all sorts of shapes and sizes and forms and so on. Word, PDF is very common. It's very easy to extract text, as we know. A lot of people have done that. Page segmentation is a big challenge, of course. You've got headers and footers, you've got graphics in the middle, you've got headings, and headlines, and so on. Bitmap images are very important. You see the image on the right there. This contains critical information, especially when you're dealing in the area of architecture and solution design. We really need to extract that. So we're doing that. Thankfully, we now have multimodal models, not language models, but they're multimodal. And we're using those to extract the relevant information, relevant being a key aspect here, from those bitmap images. Then we have to link them back to the page to make sure it's connected. More of that later. Structured graphics, same idea. There's a lot of diagrams that are in structured graphics. We basically turn them into bitmaps again. But then we have the problem of big flowcharts. How big? How big is these flowcharts? Something like this. And it keeps going. So that's a challenge. You can't really turn it into a bitmap. That example one there was about 13 megapixels wide. And that's not going to fit into your GPT-4 Vision 2,000 pixel limit. If you downsize it, you're going to lose all the text and so on. So we have a different mechanism for this specifically. It's actually not AI-based. We know that AI isn't the appropriate tool for every problem. We're actually we're transforming this using Python code into a relevant representation that we'll talk about that later. By the way, there's some interesting stuff. You may have come across this as well. We have old documents, and they get revised from time to time. And the authors sometimes don't delete the text. They just pull a line through the middle. Now, if you're doing PDF to text, that text is going to come out as if it's authoritative text, not deleted at all. We haven't dealt with that yet, but we know that's a problem. Incidentally, also comments on the side of Word documents. That also happens, because some of those comments are very significant. Looking further ahead, we might want to include video in our ingestion of data. We have a lot of training videos, internal training videos. Some teams prefer to communicate and knowledge shared through video rather than documents. We're not there yet, but we're interested in maybe doing that. Document search, well, we know about RAG, semantic hybrid. There's shortcomings, of course, with RAG, like exact matching. Here's two error codes, which mean completely different things. But from a semantic or hybrid search, you can barely tell the difference. There's more to say about RAG, bottom-up. RAG is fundamentally a bottom-up mechanism, not a top-down. Top-down searching is sometimes appropriate. Knowledge representation, and this is really the key here. We have these different kinds of non-text inputs, knowledge embodied in architecture diagrams, flow diagrams, even screenshots from an application user interface All these different kinds of, they're all bitmaps, or they're all graphics and things, but semantically they're very, very different, and they contain different kinds of information. And one of the challenges here is to extract the relevant information according to the type of picture it is. These aren't dogs and cats anymore. These aren't, it's not ImageNet. This is real stuff with, connecting boxes between components and so on. So we have to use careful prompting to extract that kind of information out. Not only the information extraction and indexing, so the semantic indexing has to be relevant, but also the data has to be in a format that the LLM can consume and start reasoning over. Remember here, we're talking about designing customized solutions, and they have to be accurate. The reason we can't go with basic RAG is because it's not accurate enough. It starts making things up. We want to be able to reason over the data that we have, so it has to be represented in a format that we can actually do that with. Hands up anyone who's had this in their data science projects, undocumented knowledge that they have to deal with? Certainly here. What do we do with that? It's knowledge that we need. It's undocumented, so what do? We document it. How do we know what to document? It's a bit of a discovery process. We're at the early stages of rolling out this tool to our internal teams. And as we find things, we add them. We basically create a big text file containing high-level, big context items such as what products is, Amdocs products is this particular customer using, what versions, what are their acronyms, things like that, and whatever else we find along the way. This undocumented knowledge text file is really a placeholder. We don't want it to exist. It really should be in the document repository, but right now it isn't, so this is a workaround. But besides that, it's also persistent, and it acts as a bit of a bootstrap for the research agent, the research process to do its thing. So we kind of need it around. The RAG mechanism doesn't work for this. By the way, even if this knowledge was in the database, it could be that it's not retrievable for some reason. It's not indexed correctly, but we need it to be there, right? This is a workaround, hopefully temporary. And as I mentioned, it guides the research process. How good is this tool that we have? Well, the initial feedback from humans is actually positive. It's not perfect, but there's room to improve. How do we measure this? Well, we ask people. We have this pop-up appears at the end of when the guy is finished using it. And we also send out a survey from time to time to ask them to rate various categories. We're looking into automated objective measurement mechanisms. And yeah, there's room for improvement there, but we're getting there. We're on the journey. So just to summarize the main things here, modeling the research process appears to be a very important thing here. RAG isn't enough. We need to do deep dives and reasoning over the data that we have. Data representation is very important here to extract relevant information, especially from images, and to be able to reason over that information that's been extracted. And handling undocumented knowledge is a necessary evil. Okay. Hope you enjoyed the talk. Thank you.